Hello, this video is for IXL, Activity A1.I.8. It is titled Solve Equations Using Order of Operations. The 3-character code for this activity is 8 November Tango. So what are order of operations? Well, I've got a little graphic here to remind us that, often referred to as Pemdas, or some of you might know it as Please Excuse My Dear Aunt Sally, where it tells us the order of the operations that we should follow to solve an expression or an algebraic expression, whether it's numerical or algebraic. And so P is for parentheses, so we do parentheses first. E is for exponents. After parentheses, we complete all exponents. Then, after we've taken care of parentheses and exponents, then we can do all the multiplication and division going from left to right. Then after we've done the multiplication and division, then we can do all of the addition and the subtraction going from left to right. It's interesting how many people assume that you have to do all the multiplication and then all of the division. In this particular arrangement here, multiplication and division have the same level of importance as does addition and subtraction. So even though they kind of show up in their own particular order within PEMDAS, we can't really say M and D at the exact same time, showing that they have an equal level of importance, or that is to say that they don't really outrank each other in the order of operations. We would do the multiplication and division going from left to right, and then finally, whenever there's nothing but addition and subtraction left over, those two are as equally important, and we would do the addition and the subtraction going from left to right as well. So here we have 19 divided by the quantity of 9 plus 10. Notice how I say the quantity of, because the parentheses here, we verbalize those using the phrase the quantity of. So if somebody were saying to me 5 times the quantity of 6 plus 3, I would know that's 5 times the quantity, and they'd say, oh, quantity of 6 plus 3, and then without them actually writing it down, they could verbally say it to me, and I would know exactly what it is that they're trying to communicate to me. So the parentheses are referred to as the quantity of. So let's rewrite our problem. Always good to do a rewrite. 19 divided by the quantity of 9 plus 10. And I'll clear up this division sign just a little bit there. There we go. So parentheses comes first, right? Please excuse my dear Aunt Sally. P's for parentheses. Let's deal with the parentheses first. So let's do 19 divided by, and 9 plus 10 is 19. So now I just have 19 divided by 19. Well, we know any number divided by itself equals 1. So in this case, Q equals 1. Next two problems here. These are fractions. I've kind of put these together for a reason. And that reason is that whenever it comes to grouping, using grouping symbols such as parentheses, it can also be brackets, or it might also be braces. Brackets, braces, and parentheses. Another grouping symbol is a fraction. Fractions have to have their numerator simplified first, and their denominators, if there's any simplifying to be done, and then you can go ahead and do the division that's involved. Why do I say division? Because every fraction is indeed a division problem. You could almost read the fraction bar as a divide sign. I could rewrite this as 2 plus 7, or to be exact, the quantity of 2 plus 7, because the numerator has to be simplified first, divided by 3 in this case. The numerator gets divided by the denominator. So with that said, I'm going to go ahead and, let's go ahead and leave the parentheses there, just for the fun of it, I guess. So I'm going to do 2 plus 7 is 9. 3, the denominator is already simplified as much as we can. Now, this is equal to 9 divided by 3, because it is indeed a fraction, and a fraction is a division problem. So we divide the numerator by the denominator. 9 divided by 3 is 3, so C equals 3. Okay, on the next one, we have 12 in the numerator and 3 plus 3 in the denominator. So let's go ahead and just kind of picture some parentheses around that denominator there and realize that we need to simplify this denominator before we can do the division that's implied by the fraction bar. So let's go ahead and bring our denominator 12 down, our numerator, excuse me. Now let's do the 3 plus 3, and that's 6. Now I can go ahead and do 12 divided by 6. This time, no need for me to write it out. I recognize it as division. 12 divided by 6 is 2, therefore U equals equals 2. Solve for j. We have an exponent here. All right, so we have 3 times, and notice there's no multiplication sign here. There's no operation sign. There's no plus, no minus, no divide, no multiply. If there's the absence of an operation symbol, we realize that that means to multiply. So 3 times 2 to the 4th power. So what is 2 to the 4th power? Let's do that over here to the side. 2 times 2 times 2 times 2. Well, I could go 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. Strategy I like to use is split them up. 2 times 2 each time is 4. And then 4 times 4 is 16. In my mind, that's just a little bit easier. So I would have 3 times 16. Now I can go ahead and do the multiplication, now that I've taken care of the exponent. And 3 times 16 should be 48. So answer is 48. I do that one mentally. I think of this as 3 times 15 plus 1. 3 times 15, that's an easy one. That's 45. 3 times 1 is 3, and 45 plus 3 is 48. A little bit of a bonus there, showing you my mental math. Next one, -5 times 3 to the 2nd power, or we would say 3 squared. So let's go ahead and do -5 times 3 squared. So we have to take care of exponents first. So this is -5. And again, there's no operation symbol between these two, so we know that that's multiply. But I'm just going to leave it as a parenthesis. 3 squared is 9, 3 times 3. And negative times positive is negative. And 5 times 9 is 45. R equals -45. Let's solve for W. So we have -2 to the 4th power divided by -2. Now, the fact that the negative sign is inside the parenthesis with the 2, and let's go ahead, I'm going to rewrite the problem. I'm getting ahead of myself. 4 divided by -2. Now, since the negative sign is inside the parenthesis, this means -2 times -2 times -2, and I think I might try to squeeze that in over here, times -2. There we go. So negative times negative is positive, right here. Negative times negative is positive, and 2 times 2 is 4. 2 times 2 is 4, and 4 times 4. In this case, and those plus signs are confusing, aren't they? It looks like it's addition. Let's get rid of those. Dink, dink, sound effects. Dink, dink, great sound effects. So, again, 4 times 4 is 16. So we end up with a positive 16. Whenever you're squaring, or whenever you're raising a negative number to an exponent, if the exponent is odd, it's going to be a negative number. If it's even, it's going to be a positive number. So the fact that the exponent is 4 is an even number, I know that the result is going to be a positive number. Let's bring that divided by -2. So a positive divided by a negative is going to give me a negative. 16 divided by 2 is 8. Our answer is W equals -8. Let's solve for X. We have the quantity of 1 plus 2. 1 plus 2. And we're going to multiply that times 14. Again, no operation symbol here, so we know that this is multiplication. Let's simplify this 1 plus 2 that's in parentheses, and we're going to get 3. Bring down that 14. Now we know this is 3 times 14, and I'm thinking of that in my head is 3 times 10 plus 4 is what I got going on in my head. So this is 30, and that's 12, so that's going to equal, what, 42, right? So the answer is 42, positive 42. Solve for H. 3 to the 4th over 3. Now, there's a rule to exponents that I'm wanting to cheat at here, and I realize that this is 3 to the 1st, and I know that that means that this is equal to 3 to the power of 4 minus 1, which is equal to 3 to the 3rd, which is going to equal 27. But this lesson's not about the properties of exponents, so pretend I didn't say that, but it's true. All right, so let's simplify 3 to the 4th over 3. Let's go ahead and simplify the 3 to the 4th. 3 times 3, and again, let me go ahead and show you that little trick there. I could do this the hard way and say 3 times 3 is 9, times 3 is 27, times 3 is 81, and I could get to 81 that way. Squeeze 8 in there, I guess. Or I could say 3 times 3 is 9. 3 times 3 is 9, and 9 times 9 equals 81. So I think that's a little bit easier for me to do that way than it is to do the 3 times 3 times 3 times 3. Group them together. And let's bring that 3 over. And now 81 divided by 3 is 27. And for the most part, I really don't have 81 divided by 3 memorized in my head that well. I just so happen to know it's going to be 3 to the third, which is indeed 27. J equals negative 40 over 2 to the third. So I have negative 40 over 2 to the third. And I need to go ahead and simplify that 2 to the third in the denominator. Well, that's 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So that's going to be 8. Now I know this is a division problem. Negative divided by positive is going to be negative. 40 divided by 8 is 5. So J equals negative 5. Solve for C. So I've left a little more space here instead of doing 2 problems per page because it might take a little more space. Realize we have to do the numerator first. So let's take the quantity of 5 plus 8 times 2. Do a rewrite, and then let's do 20 minus 18. And remember, we can go ahead and put this in parentheses too, because we realize we have to simplify both the numerator and the denominator in order to work this problem out. So let's go ahead and simplify the numerator. 5 plus 8 is, 13? And we're going to multiply that times 2. And let's go ahead and do the 20 minus 18. And 20 minus 18 is 2. Now, I could cancel those 2's out, but we won't do that. That's another lesson as well. So let's just do 13 times 2 is 26. And let's bring that 2 over. Now we have 26 divided by 2 is 13. So C equals 13. Solve for R. Well, always good to rewrite the problem. So let's do quantity of 2 plus 2. And we're going to multiply that times a negative 12. And for our denominator, we're going to have negative 2. Notice that the negative sign is inside the parentheses. That's going to make a difference. And plus 20. All right. Let's go ahead and simplify the numerator. 2 plus 2 is 4. And I need to multiply that 4 times negative 12. And now I need to deal with this exponent right here. Now remember whenever I told you that a negative number raised to an exponent, if it's even, produces an even result or a positive result, and if it's odd, it produces a negative result. Well, 3 is odd, so I know that my answer is going to be negative, and 2 to the third power is going to be 8, so that's a negative 8. And what the heck, we'll go ahead and leave it in parentheses as well. Let's bring our plus 20 over. Now let's go ahead and do 4 times negative 12. That's a positive times a negative, so that's going to be negative, and 4 times 12 is 48. And then we have negative 8 plus 20. So I'm adding together a negative number and a positive number. So I actually want to subtract those. 20 minus 8 is going to give me, 12, right? And 20 has a greater absolute value than the 8 does. So I want to use a sign that matches the one with the greater absolute value. 20 is positive, so 12 is going to be positive. Now I can go ahead and do this division here. Remember, every fraction is a division problem. So negative divided by a positive is going to be negative, and 48 divided by 12 is going to be 4. Our answer is 4. Since I know the answer is 4, I'm wondering what I could have canceled out. Mental math, that shortcut it, but oh well. Final example here for order operations. Going to solve for R. So let's go ahead and do our negative 5 times negative 3. And then we have 16 minus negative 3 times negative 7. Okay, this one might get a little bit tricky. So let's go ahead and do that numerator first. That's the easy part. Negative 5 times negative 3. Negative times negative is positive. 5 times 3, that's going to be 15. Now, down here, we need to go ahead and realize that this is subtraction right here. And right here we have multiplication. So we need to deal with this multiplication first. So let's do our 16 minus. Now, let's go ahead and I'm going to change my color to green so you can see what I'm grabbing right here. I'm grabbing the -3 times -7, and I'm going to solve that, okay? So negative times negative is positive, and 3 times 7 is 21, so I have 21 here. Now let's bring the numerator, 15, over. Now I have 16 minus 21. Now I'm going to move this to a smaller problem down here. I'm going to take 16 minus 21. I don't like 16 minus 21. I'd rather do something different. And here's what I'm going to do. I'm going to keep the first number the same. I'm going to change the sign from subtraction to addition. Then I'm going to take the opposite of the number that follows it. So the opposite of positive 21 is negative 21. The reason I like doing this is then I'm doing the addition of integers. And I know the shortcut for the addition of integers is that if one number is positive and the other one's negative, then I actually just subtract those. So 21 minus 16, well, the difference between 16 and 21 is what, 5, right? Now 21 has a greater absolute value than 16. So since 21 is negative, I want my answer to be negative. So this over here simplifies to -5. I know whenever you kind of work to the side, you kind of forget, where was I getting this? Where does it go to? But that -5 goes up here as the denominator. Now I have a positive number divided by a negative number, so that's going to give me a negative result. And 5 divided by 3, or 5 divided by, throwing the answer out there already. 15 divided by 5 is 3. There we go. Long video trying to get through it. -3, so -3. All right, so those are all of my examples for IXL Activity A1.I.8 Solve equations using order of operations. Good luck with your activity.